Okay, we're in Year 9 Notes. This is Unit 7 and we're on Pythagoras Theorem. The first page here is an investigation, and so I'm not going to be doing this in our notes here. You maybe want to copy it off one of your other pupils in your class, or try it for yourself. It says on squared paper, draw 6 right angle triangles accurately. I'm sure I could summon up a wee bit of squared paper here and just show you exactly then what they mean. So what you would need to do, here's some squared paper, and if I then draw one, and again I'm just going to pick a reasonably random one here, so there would be one side. Let's do another side, and if you measure these in as accurately as you can, so with your ruler you would measure the length of the 3 sides of this. Oh goodness, I'm going to stay with that. You'd measure the length of the 3 sides of that triangle, and then you would fill in the information here. So you get the shortest side, you find the length of that. If you measure that, that's going to be 2.5 centimeters, and so if you square that, you get 6.25. The middle side is going to be 1, 2, 3, 4 centimeters. So if you square that, you get 16, and then with your ruler you measure this really accurately as well as you can. So that there, what does that look to me to be about 4.7 maybe, and so you can just about see that. It's probably off the bottom. So about 4.7, so again you square that and you see if you can find in the relationship between those different things. Anyway, if you do that, you should find that the longest side, which is called the hypotenuse, which is a very strange name, and we then label it C, and it's at C squared equals A squared plus B squared. In a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other 2 sides. If you label the 2 shorter sides A and B, let's do a wee diagram, might be helpful. Sorry, I haven't used my ruler. 2 shorter sides A and B in a right angle triangle, and this is C, then C squared equals A squared plus B squared, and that's what Pythagoras theorem states. It's a very famous one. It's for right angle triangles, and it really helps us if we're trying to find the third side of a right angle triangle, which is what we're going to do in a wee second. So that's then take away that. I've got to admit that I think in these examples the A, the B and the C here are really unhelpful, so I'm going to get rid of them, and we want to label our sides. So C was our longest side, it's always the one opposite the right angle, and so that's going to be C, and then the other 2 don't matter, A and B. And if we're going to find C, we would go C squared equals A squared plus B squared. C squared equals 4 squared plus 7 squared. C squared equals 16 plus 49. C squared equals 65. And then if you know C squared and you want C, you have to find the square root. So it's going to be the square root of 65, so you need your calculator for that, and we would then go the square root of 65 equals, and it's 8.06, and the 3 significant figures, so 8.06 centimeters. Next one then, numbers are a wee bit bigger, but it's very similar. Again, these are unhelpful. We label our sides A, B and C. The 2 shorter ones are A and B, doesn't matter which is which, and C then is our longest side. C squared equals A squared plus B squared. C squared equals 12 squared plus 19 squared. C squared is 144, and then 19 squared gives 361. C squared equals 505, and then C, you can see that okay, can't you, is going to be the square root of 505. So we want the square root of 505, and that gives us 22.5, the 3 significant figures. And we end up then with that. Sometimes as well we actually have to find the shorter side, and we need to be a lot more careful here. So our answer shouldn't be bigger than 19, otherwise we've messed up. And I'm actually going to flip around our Pythagoras theorem for this one. Anyway, label the sides first of all, A and B and C. C always has to be the longest one. And I'm going to write it as A squared plus B squared equals C squared. So I will have 12 squared plus b squared, because that's the one I'm trying to work out, equals 19 squared. 144 plus b squared equals 19 squared gives me 361. How do I get the b squared on its own? I have to take these away, so it's going to be 361 take away 144. So 361 take away 144, and that of course gives me 217. B squared is 217, and then b is the square root of 217. If I take the square root then of the answer, that's going to give me 14.7, and that's centimeters. Again, this needs to be smaller than this. If it's not, you've messed up somewhere, because we're finding the shorter side. Let's take a look again at our second example. We have 12 and 8 here, and we're trying to find this side here. Again, these can be quite unhelpful, but let's ignore them. C has to be the longest one. Let's go for A here and B here. A squared plus B squared equals C squared. A squared plus 8 squared equals 12 squared. A squared plus 64 equals 144. A squared is 144 take away 64. So a squared then is going to be 80. A is the square root of 80. I'll put that under a calculator. And so we end up then with 8.94. And that's centimeters.